Hello guys, welcome back to the channel. So today also we are going to continue our chapter, that is Laplace transform, and today we are going to see how to find Laplace transform of derivatives. So let us see the formula. Laplace transform of the derivative of any function of t, that is Laplace transform of f dash t, is equal to minus f of 0 plus s into Laplace transform of f of t. Now let us see an example to get you an idea about how to apply the formula. So the given example is, you have to find Laplace transform of d by dt of sine 3t by t. Here d by dt of any function, that is f dash t. Okay, so d by dt of sine 3t by t is the whole function, is nothing but f dash t. That means f of t is equal to what? The function which is inside the bracket, that is sine 3t by t. This is your f of t. So see the formula. If you have to find Laplace transform of the derivative of any function, that is Laplace transform of f dash t, you have the formula minus f of 0 plus s into Laplace transform of f of t. So in first step we will find Laplace transform of f of t, that is Laplace transform of this function, that is sine 3t by t. So let's start. First you have to find Laplace transform of sine 3t. Okay, so we have the direct formula for Laplace transform of sine 80, that is a upon s square plus a square. Here a is 3, so this will become a, that is 3 upon s square plus a square. So s square plus 3 square, that is 9. Now in previous lecture we have seen how to find Laplace transform of any function divided by t. Okay, that is sine 3t by t. So what's the formula? The formula is Laplace transform of f of t by t is given by integration s to infinity, integration s to infinity phi of s, means Laplace transform of the given function, that is this. So let's write 3 outside the integral sign, 1 upon s square plus 9 ds. Okay, now we have to find the integration of that function. Now we have the formula for integration of 1 upon s square plus a square. Here a is 3 square. Okay, so a is 3, right? So apply the formula. First of all write this constant, that is 3. Then 1 upon a, that is 1 upon 3 tan inverse of s upon a, that is s upon 3. Now the rule of definite integral, that is we have to put the limit, that is s to infinity. Okay, now this 3 and 3 get cancelled. Now apply the limits, upper limit minus lower limit. You know that tan inverse of, in place of s you have to put infinity, that is upper limit. So tan inverse of infinity is pi by 2. So this is your upper limit, and now for lower limit, in place of s you have to put s. So we will write as it is, that is tan inverse of s upon 3. And we have the formula pi by 2 minus tan inverse of s is equal to cot inverse of s. So this will become pi by 2 minus tan inverse of s by 3 will become cot inverse of s by 3 according to the given formula. So this completes your one part of the formula, that is Laplace transform of f of t. Now see here, it is given that you have to find f of 0. To find f of 0 you have to just put 0 in place of t. Okay, so this will become sine 0 by 0. but 0 should not be in the denominator because the function will be not defined. So for that we will use the limit, that is limit t tends to 0 sine 3t by t. Now see, we have the formula limit t tends to 0 sine t by t is equal to 1. So if you have 3 here, you also should have 3 in the denominator. So if we divide by 3, then you should multiply with 3 also. So the answer of limit t tends to 0 sine 3t by 3t according to this formula is 1. But here it is 3. So 3 into 1 is equal to 3. So you have f of 0 is equal to 3. So this completes your procedure to find out f of 0 and Laplace transform of f of t. Now we will write our answer, that is Laplace transform of f dash t. Okay, that is your this function. So Laplace transform of d by dt of sine 3t by t is equal to, according to the formula, minus f of 0. So minus f of 0 is 3. So minus 3 plus s into Laplace transform of f of t. So Laplace transform of f of t is cot inverse s upon 3. So this is your final answer. So this is the step-by-step procedure to find out Laplace transform of derivatives. Okay. So now we will see how to find out Laplace transform of integration of any function of t. We have the formula to find Laplace transform of any integral. So if you have to find Laplace transform of integration 0 to t f of u du, then it is equal to 1 upon s phi of s, and phi of s is nothing but Laplace transform of the given function. Now let's take an example to get you an idea about how to apply the formula. So the given example is, you have to find Laplace transform of integration 0 to t sin u cos 2u du. Okay, so if you compare your example with the formula, you will see that this f of u is nothing but sin u into cos 2u. Okay, so in the formula they have given you have to find phi of s. That means you have to find a Laplace transform of f of u. So let's find out. So Laplace transform of sin u cos 2u. So we don't have any direct formula because here it is multiplication sign. So let's convert the given function using the formula sin a cos b. Okay, so this will become 1 by 2. So 1 by 2 Laplace transform of sin of a plus b. So sin of, here a is u and your b is 2u. So a plus b will become u plus 2u, that is 3u plus sin a minus b. So a is u, b is 2u. So this will become u minus 2u, that is minus u. Okay. Now we have the formula, that is sin of minus x is equal to minus sin x. So sin of minus u will become minus sin u according to this formula. So let's write half sin 3u minus sin u according to this formula. So now let's find out the Laplace transform of this function. So for that we will use the formula for Laplace transform of sin 80, a upon s square plus a square. Here a is 3, so this will become a, that is 3 upon s square plus a square, that is s square plus 3 square will be 9. Now here a is 1, so according to the formula minus a, it is minus 1 upon s square plus a square, s square plus 1 square is 1. Now we have found out phi of s, okay, that is Laplace transform of f of u. Now let's apply the formula, that is Laplace transform of integral 0 to t f of u du. Here our f of u is nothing but this function, so integral 0 to t f of u, that is sin u cos 2u du is equal to, according to the formula, 1 upon s, so let's write 1 upon s phi of s. What is your phi of s? So this, so 1 by 2 into this bracket, that is 3 upon s square plus 9 minus 1 upon s square plus 1. This is your final answer. That means the main part is to find out phi of s, that is Laplace transform of f of u, and in the last step you have to just divide your Laplace transform, that is phi of s, by s to get the final answer. So I hope you got the step-by-step procedure to find out Laplace transform of the given integral. Now let's see a different example which is based on this example. So we will write this answer of this Laplace transform here. So let's write 1 upon 2s 3 upon s square plus 9 minus 1 upon s square plus 1. We have written because we will need this answer to solve the next numerical, which is based on this numerical. So the given example is, you have to evaluate integration 0 to infinity e raised to minus 4t integration 0 to t sin u cos 2u du dt. So if you see this part, that is the part which is inside the bracket, this is nothing but your previous numerical. Okay, so to start this example you have to first find out Laplace transform of the given function which is inside the bracket. Okay, so that is 0 to t sin u cos 2u du. Now using the steps of previous numerical, we will first find out the Laplace transform of this function, that is 1 upon 2s 3 upon s square plus 9 minus 1 upon s square plus 1. Now we will continue from here. So the Laplace transform of any function, okay, so that is Laplace transform of any function of t is nothing but, according to the definition, it is 0 to infinity e raised to minus st f of t dt. Here f of t is this function. Okay, so 0 to t sin u cos 2u d. This is your f of t. dt. So according to the definition of Laplace transform, we have written this step. Now if you see this step or this integral, and if you compare with your example, you will see that the difference is only here. That is, here it is e raised to minus 4t and here it is e raised to minus st. So if you have to convert this e raised to minus st into e raised to minus 4t, you have to just put 4 in place of s. So for s is equal to 4, this will become integral 0 to infinity e raised to, in place of s we will put 4 e raised to minus 4t into 0 to t sin u cos 2u tu dt is equal to. Now if you substitute s is equal to 4 here, then you have to also substitute s is equal to 4 here also. So this will become 1 upon 2 into s is equal to 4. So 2 into 4 into 3 upon s square will become 4 square, that is 16 plus 9 minus, let's write 4 square here, minus 1 upon s square, that is 4 square plus 1, and the final answer will be 1 upon 2 into 4, that is 8, 3 upon 4 square, that is 16 plus 9 will be 25, minus 1 upon 4 square, that is 16 plus 1 is 17. This will be your final answer. Now we will see another example of this type, that is Laplace transform of triple integral 0 to t cos 3t dt cube. So in the previous numerical we have seen a procedure to find out the Laplace transform of the single integral, but from this formula you can derive this given formula. And what's the formula states? That Laplace transform of n number of integral of f of u du n time, that is n number of integral, is given by the formula 1 upon s raised to n Laplace transform of f of t. Okay, so Laplace transform of f of t is nothing but phi of s. The difference between these two formulas is just here, that is you have to take n in the power of s. And what is n? So n is nothing but the number of integrals, that is here it is triple integral, therefore n will be 3. Okay, rest of the part is same as the previous numerical. So let's start the first step, that is procedure to find out phi of s, that is Laplace transform of f of t. Here f of t is cos 3t. So according to this formula, that is Laplace transform of cos t, it will become s upon s square plus a square. Here a is 3, so 3 square will be 9. Now apply the formula, that is Laplace transform of triple integration 0 to t f of t, that is cos 3t dt cube is equal to 1 upon s raised to n. And what is n? So number of integrals. So here triple integral is there, so n will be 3, and rest of the part is same, that is phi of s, which we have found out in previous step, s upon s square plus 9. So to write final answer, we have to just cancel this s, this cube will become square. So the final answer will be 1 upon s square into s square plus 9. So this is your final answer. So I hope you understood the examples which we have seen in the today's lecture. So this completes your chapter, that is Laplace transform. To learn other chapters of engineering mathematics, just go to the playlist section and select the chapter which you have to learn. Thank you very much for watching.